Hello, everybody, and welcome back to my microservices series. Now we're going to talk about building microservices or the different building blocks that we need to create our first microservices. So let's start. The first thing we which have to think about when we want to have microservices architecture is the hosting environment. So basically, we need three different different hosting environment. The first one is development environment, is when your developer is going to code the microservices and need to debug the application or to debug the service locally. The second environment, kind of a staging environment that could be one or different level of staging environment like integration tests, user acceptance tests, or pre-production environment. But the main idea of the staging environment is something is a production-like environment when we can run the test. So we can test the application manually or using some automation to validate our microservices is working as expected. And the third environment is the production environment. We also need some environment that's needed to host the application for the end users. So if we think about all this environment, there are several techniques that we can use to build up this environment. The first one using virtual machine that can be in your local data center or can be also using some EIs, some cloud provider. So the idea is to have a VM per microservices, but it's something is very challenging because we have to manage a big number of of a VM. Your application maybe would be built up using uh, several microservices, 12 microservices, 20 microservices, and which microservice is going to scale out independently so we can run into a huge number of a VM that we should to manage. And the operational challenge become very, very complicated. And in the meantime, we have to manage the service discovery because each VM will have its own IP address and or maybe its own domain DNS or mobile domain name. So something is very complicated to manage microservice architecture using the classical way with a virtual machine, even if you're using some cloud technology like Azure or AWS. So the second possibility that we have is to use a platform as a service offered by your favorite cloud provider or some cloud foundry technology. So this platform of the services that can bring automated scale out, something we can configure in our system, have a scale out based in some metrics like a CPU per center or the memory used by the microservice. DNS addresses are also generally managed by the cloud provider and load balancing, something that will happen behind the scene. We can, if you have many instances of your services, the full balancer is configured behind the scene and can balance the load between different instances of your microservice. The security and the monitoring usually are easy to configure when using some cloud provider like Azure or AWS. Sure, you have the knowledge of those platform, but something is very, very quick to set up and very easy to set up. You have also the possibility to have kind of serverless microservices using kind of Azure Function or AWS Lambda, but those technique are binded to your cloud provider. If you're using Azure Function or AWS Lambda, you cannot host AWS Lambda in Azure and Azure in AWS Lambda. So to create some binding in your cloud provider and your solution is not cloud agnostic. So we come to the third possibility that we have is using container. Container is something is a portable that can run anywhere. It can run in your data center, in developer environments, in any cloud provider. So something is portable that can run it in anywhere. It's easy to run locally. You can just have if you're using Docker as a container engine, Docker run and you have your services up and running and you can use Docker Compose if you have to create some collaboration between different microservices. So Container, what it brings the possibility to be a cloud agnostic. That means that your solution does not depend to the cloud provider. You can run it in any cloud provider. And sometimes we can combine the benefits of a platform as a services with the containers. It's called that the container as a services. We can have this offer in the most common cloud provider like Azure, AWS, or even Google. So, why we should? I'm not saying that we must use containerized microservices because building microservice and delivery is time consuming. You have to set up not only the code, you have also to take care of all non-functional requirements, how to install dependencies in your services, how to set up the configuration. If, for example, you are using the VM at every time that we start a new instance of your server, so that this VM is created, so you should install all the dependency. Maybe you should install your Java runtime environment, you should install the Maven and all the dependency that you need. So, and also to set up all the configuration, how to connect to the database, how to connect to the to the external services or the external servers. With the containerization, all those dependencies are built in your container, and you have just to pull your container and start your container. Something can give us a, a large benefit at operation at runtime. Uh, as I said, it's a trivial start. Everything with Docker Compose is there. You already have your configuration, or already you have your your image of your Docker image built using your Docker file or some other technology. And also that have us the ability to debug our code uh, in the development environment. Imagine that you are facing some challenge or some issue, and you want to debug your code to detect the issue. You can do that using any environments, development environment, and you can debug the code running inside the container. So as I said, containers are not required for microservice technology. There are some architecture or some projects that use Azure Function, EWS Lambda, or other technologies. I didn't see in my life any microservice architecture using VM. That's something I think we can start with that, but we are just if the scalability grow up of your application, we're just going to face a huge problem about the collaboration between different VM. But when we use containerized architecture, that bring the automation in our process, not only in the development step, but also in the operation. We will see that in the chapter we're talking about the delivery. But if you are building your container, your Docker image, so it can be easy to run between different environments. So imagine that you have your container image, you can test it in user acceptance test. If everything is working, you take the same container, the same image, and run it in the production environment. Something can give us the ability to automate test and to automate the delivery of your microservice. So creating microservice, we talked about the environment, how we're going to build our development and runtime environment. Now, if you start to write your code, the points I'm focusing here, and this is a requirement for the microservice architecture. If we have to respect the definition of the microservice to avoid sharing repositories between microservices. Each microservice should and must have its own repository that's going to automate or run code and to do all the stuff that we need. So avoiding sharing repositories between microservices that avoid the coupling between microservice. Each microservice, for example, we can also have, for example, uh, for some microservice, you can use in Bitbucket as a repository provider. You can use another repository provider, GitHub or other one for for another microservices. And the second must to have when building microservice architecture is automated tests. Okay, because we are using distributed architecture. We have a lot of services building. We should to be to be aware about the burden that we bring to this lot of independent microservice. So the only way we have to ensure that everything is working as expected is to have automated tests. When I'm talking about automated tests, sure, I'm thinking to the functional test, to the unit test, and all the stuff. But there are also all the non-functional tests. There are something called in DevOps. Uh, and that was called the shifting left. We should just shift at left all the performance tests, the security tests, the integration tests to be sure when I'm going to deploy my microservices is work not only working as expected, it's secure. There's no vulnerability in the code. The performance will is acceptable. We build kind of acceptance criteria before deploying my service in the production. We should to check all the items that I'm aware of, like performance, like security, like a unit test, and all those stuff should be made automatically. We cannot have microservices in the staging environment, and we need to run, I don't know, performance test manually or security test manually before deploying it. So, talking about this, we have to distinguish between three level of test. The first one is a unit test, and the fast test to run. We build your method. We should have test first approach, and everything is testable. And with microservices, we should have a high code coverage. In my opinion, should be above 90%. So to make sure everything is going to work as expected, I'm not creating the regression when I'm changing, for example, my code. Because with microservices, agile approach, and we only we always have this rewrite our code. So everything we are refactoring our code every time we are refactoring our code. The second step or the second level of the test is the service level test. This is what I call the contract test. We talked about the contract. We want to create microservice. We have a contract. The contract is to tell other services, this is my my business capability. I'm exposing my business up capability like that. So the test I have to do is in isolation. Maybe we can use some more collaboration because if we need to communicate with other external services. But this test is going to ensure I'm respecting my contracts. I'm exposing my business capability, respecting my contract. Maybe this can be kind of using an API, kind of Postman test tools or something like that, or SOAP UI test or something like that. But you should to make sure with this level of test, this is the most important one, to make sure I'm exposing my business capability, I'm my respecting my contract. So when I'm communicating with the external mode, with external services, I expect my contract. If you want to enroll a new customer in my website, this is the way I'm going to enroll this new customer. This is the required field. This is the business requirements and all the stuff regarding this business capability. Another way, another level, sorry, about the test is end-to-end tests. And in the end-to-end test is production-like environment. So we're not going to test application at all, but just to be sure that the integration between different components of the application is working as expected. We can have, for example, can say that in e-commerce platform, I'm browsing the catalog. I'm going to choose some item, put it in the basket, and after that, I'm going to make an order. That can be kind of a smoke test or something like that to be sure the connection between the different item of the application, of different components of the application is working as expected. So, we talked about the hosting environment, we talked about the tests. Okay, we think about the tests before starting the development. So always test first. There are many approach of TDD or BDD. I love BDD approach, but it's not enough. If you're working about microservice, think about the hosting environment, about the test strategy you are going to implement in your microservice architecture. But we should also use some microservice template or example. So I'm talking about templates, I'm not talking about the framework at all. It's what I talked about in my first chapter is the standardization which makes sense. We should to standardize our microservice. Standardized microservice doesn't mean that we should use the same version of framework or the same kind of framework. Let's have a look about this five item. The login, for example. Each microservice can use its own technology. If you're developing, I don't know, microservice using Java is going to use log4j or if, Verilog if using .NET or other technology if using Golang. But the most important point is to use the sum login template. When I go into log something in our log, that should use the same format, the same template. Why? Because, and again, because it's distributed architecture, we need to collect the log from different microservices, and maybe we are using some technologies like Datalog or like Splunk to explore our log. So to explore efficiently those logs, they should respect the same format. We should just standardize the way that we are going to log. I'm not saying that we should to use the same framework for the log, but I'm just saying that we should to standardize the way we are going to log. The same thing about the health check. The health checks is the way the service is exposing its status. Let's say that we have a service catalog. How can I be aware about the status of my catalog? Generally, it's the endpoint exposed by the service that I'm up and running and I'm not, but also are my dependencies are configured correctly. Imagine that we have a microservice and a microservice, and this microservice is using SQL database, is using I don't know, publishing information in Kafka on another queue. So my health checks endpoint should expose the status, the internal status of my service. We're going to say, I'm up and running. My SQL server is correctly configured. I'm connected to the Kafka or Oracle and all the stuff that the service it depends on. So what we should to do here is to have same of API contact of the health check. So this endpoint should respect the same format because we are using behind the scenes some technique or some technologies like Datadog and like Grafana or other technologies going to gather the information of the health status of our services and maybe that we have some dashboard to say, okay, this microservice, for example, is up and running. Another one is they have a problem with connection to the database or they have problems connecting to another external services. So this way the service is going to expose this health should be standardized. They should use the same content, if you can say that. Another point that we should to make sure about this is the configuration. We are injecting the configuration using the same way. Okay, let's have an example if we are using containerized microservice Docker or another containerization technology. The way we inject the configuration should be the same. How we are going to inject sensible information using secret or using something like that. How we are going, for example, to share information between microservices. I'm not saying here that we can create coupling between microservices, but I don't know. Microservices share the same certificate to validate some stuff, for example. How do we are going to share the certification? How to come to inject the configuration within our containers? As you know, when using containerized technologies, we are not making the configuration inside the image, the Docker image. So we inject at runtime those configuration of the set that give us the ability, for example, to move the same image from different environments. If I'm starting, for example, my microservices in the test environment, I'm going to inject the test configuration. So the same image can run in the production environment, but at this time, we're going to inject the production configuration. Uh, the fourth point that we should standardize also is the authentication. We know we're using microservices, which there is security in somewhere, and the security is usually authentication. The microservices should know who's calling my services or making the request. So generally, you can use. some technologies like Jot token or other thing, but we should just to use the same technology. But what will happen? You are the end user using your mobile application. You're going to connect or to request the catalog, and after that you're going to request the basket. After that you're going to request the order. So you just made a connection or login using the same technology. So all my services should implement the same way to check, for example, your job token or to check your authentication. Another point, or the last one, is the build script. So where I talked about the automation is the key success of the microservices architecture, and this automation in the build, they should use the same, not the technology, but the same standard. If we have, for example, we say, okay, we have a microservices. Before deploying my microservice to the production, there are some acceptance criteria or some that we should check, and they should be the same acceptance criteria. We cannot say, okay, I'm deploying, for example, the basket, I don't have to check the security for this one. They should go on the same pipeline, for example, unit test, code quality test, performance test, security test, and after that they can go to the production environment. So the build script should have the same steps or use the standard the way the micro is going to be built and deployed to different environments should be the same. So we guarantee that all my services, before they go to production, they go to the same pipeline, even if I'm not using the same technology. So why some benefits of the service template? So they reduce the time to create new microservice because we have the standard already defined, and this the job of the architecture team, not of the development team. And we have also some tools. I said, okay, we are consistent tooling. We are not saying that all the service they use the same tools, but the way our tool is going to be used, we have some standard. We know you'll use some log technologies or some log tool, but your log format should be the same in different microservices. They increase the development productivity because your developer is not going to think about the non-functional requirements, but only about the functional requirements, and all the non-functional not framework, but that functional template is already here that can be used by your developer. And also we have the ability to run in different environments. You can run your microservice in isolation in your development environment, but because using the same build process and the same configuration injection, so we can run it also in the full application context using Docker Compose, for example, or we can run the same thing, same kind in the production environment. So thank you for having me and see you in the next chapter.